Welcome back to Talk Study Center. So today I want to work some questions, some problems that your examiners want you to understand on functions and also on curve sketching. On functions and also on curve sketching. So I'll try to tackle the most difficult one that I think might be difficult for you. Then from there, if you have anything that is difficult, please don't forget to ask. Don't forget to ask. Don't forget to ask so that I help you. Just write your questions in the comment section. I hope on this video I'll put my number there. If you want my help, I'll help you on that. So let's get into it. So the first question says that f of x or functions of f and g, each with the domain real numbers, are defined as follows. So f of x is equals to 3x plus 2. G of x is equals to x squared plus 1. So the same applies to write something like this. We say that in our function video, that to write something like this one, write something like this one is the same. Is that the notation that is used? Different notation, but it means the same thing. So state the range of f and the range of g. So we said that on the range of this one, it was a set of what? Of real numbers, right? So the first question is saying f of x is equals to 3x plus 2, 3x plus 2, 3x plus 2. So we said that when you are finding the range of values of a linear function, what do? You create a table, what? A table of value. Create a table like this, x, this, y. So this one is a set of real numbers. So we'll have to, starting from 1, 2, 3, 4. So when you put 1 here, 3 times 1 is 3 plus 2, it is 5. Then 2 times 3, which is what? 6 plus 2, 7. So you're starting from 5. So the range of this one is 5 up to positive infinity. Then when it comes to the range of this one, we say that we use the line of symmetry to find the value of x. So a is 1, then b is equals to 0. So line of symmetry is what? It's 1. So it's something like this graph. It's cutting at what? It's cutting at 1. So f of x greater than or equals to 1. So this will be the range of these two things. So the second one, give a reason to show whether or not each function is one-to-one function. So if you sketch the graph of this one, it will end up something like this. This is the graph which is cutting at 2 here. Then the other one is this one. So when you draw a horizontal line, we use the horizontal line method. When you draw a horizontal line, when it cuts at one point, use the horizontal line, it shows that it's a one-to-one function. So this one is a one-to-one function. Then again, when you use the horizontal line like this one, it's cutting at 2 points, So this one is not a one-to-one function. It's not a one-to-one function. It's many to what? It's many to one. So this one is a one-to-one function. This one is many to one function. So that's how to show. That's how you show it. You just do this and do this. Then the other one, find the values of x given that f of g is equals to g of f. Right? So f of g, this is a composite function. We are putting g of x in what? In f of x. So in f of x, we put g of x. So g of x is x squared plus 1. Then f of x, 3x plus 2. So in this case, 3 open bracket, x squared plus 1 plus 2 must be equals to 3x plus 2 squared plus 1. Then you expand another 3x squared plus 3 plus 2 will be equals to 9x squared plus 6x plus 6x plus what? Plus 4 plus 1. When you simplify here, is 3x squared plus 5, which is also equals to 9x squared, which is plus 12x plus 5. Then you collect the like terms, so it will be 9x squared. It will be 9x squared. 9x squared plus 6x squared minus 3x squared minus 5 plus 5 is equals to 0. So this one is 0. So the answer is 6x squared plus 16. Is it 16x, right? Yeah, it's 12. 12 squared is equals to 0. Then you factor out 6x. X plus what? Plus 2 is equals to 0. So this one is equals to 0, or x plus 2 is equals to 0. So x is equals to 0 or minus 2. So find the values of x. So this will be the values of x. So that's the first one. Question says that given that f of x is equals to x plus 4 over x plus 1, describe the geometric transformation required to obtain the graph from f of x is equals to 1 over x. So first of all is for you to draw the graph of 1 over x. We say that the general graph of this one is this. This is the general graph of this one altogether. So there's something which is known as the line of asymptote. What is the line of asymptote? A line of asymptote is a line that a graph will never cross. The graph that will never cross. For example, this graph will never cross this line, and also this graph will never cross this line. So we have vertical lines of asymptote, then we have horizontal line of asymptote. So the vertical lines of asymptote and what? Horizontal lines of asymptote. So in this case, the vertical lines of asymptote, x is equals to 0, then the horizontal is equals to 0 altogether. So after that, you move on to your function, which is x plus 4 over x plus 1. Then you perform long division. You perform long division. X into x, it's 1. 1 times x, which is x plus 1. Then you less, which is 0, which is 3. So f of x, it will be equals to 1 plus 3 over x plus 1 altogether. So this is the graph that you want to sketch. That's the graph that you want to sketch, which is f of x is equals to 1 plus 3 over x plus 1. So first of all, we have f of x is equals to 1 over x, right? Then from this point, this is the graph. This is the graph. This is the graph. Then from this point, please, whenever you are applying your transformation, you start by stretch first. From stretch, you move on to reflections. From reflection, then you end up with what? With translation. So we have to stretch this one. It's 3f of x. So it's the same as 3 over x, right? And we said that if it is something like this, we multiply every y term by 3. So if you multiply every y term by 3, in this case, the y is 0. So 3 times 0 is 0. So the graph will remain unchanged. The graph will remain like changed, something like this, to remain unchanged. Then, so the first transformation is this one. Then the second transformation, what is happening? We want to this one now, which is f of x plus 1, 3, which is equals to 3 over x plus 1. We said that this one only, this one is staying for f of x. It's f of x. It's f of x plus a. And we say that this is translation in the x-axis, but when there's a positive sign, then you're moving to the negative side. So in the graph, it is moving like this. So the vertical line of asymptote, this was 0. It was on 0. So we're adding 3. We're adding 1 rather. Here we're adding 1. So moving 1 unit to this side. So it will be something like this. So this one with negative 1. So this graph will shift to this side. Then the other one will shift to the other side like this. So this is the graph of this thing. Then number 2. Then number 3, we want now to sketch something like 1 plus 3 f of x plus 1, which is equals to 1 plus 3 x plus 1. So we want to apply the 1 f of x plus a. We said that this is translation, right? We say that this is translation again in the y-axis, but going upwards with a unit. So in this case, we are going upward with what? With 1 unit. So the line will move upwards. So it will move on the line of asymptotes up to 1. So there's 1 here. And also we already have the other one, which is minus 1, the other one from this part. So the graph, our graph, it will be something like this. This will be our what? Our curves. So the question, if it asks you describe fully the transformation, so we stretch it. We stretch the graph in the what? In the y-axis by scale factor 3. Then from this point, move on to this point. We translate the graph in the x-axis by scale factor 1 to the negative direction. Then the last one, we also translate the graph in the y-axis by translation vector 1 going upwards altogether. So this will be the description of the what? Of that question. So the main reason why I drawn this is for easy visualization. to really understand the concept. But when you really understand it, there's no need for you to draw the graphs, something like this.